When we talk about rotary motion, we're always going to be talking about wheels. Okay? Now, wheels are really interesting machines because they allow for more efficient movement. It's easier to roll something down, a surface than it is to lift it and actually carry it down that same surface. The whole concept of wheels, okay, deals with two different types of simple machines. And unfortunately, they're both considered simple machines when in fact, they're the same thing. Okay, we're going to be talking about pulleys in this section, but a pulley is a wheel and axle. And what I mean by that is that every wheel in existence, first of all, is circular, okay, and that wheel has some kind of, thickness to it. That was horribly drawn. And in the middle of that wheel, we have a rod that basically allows that wheel to go around and around and around. Okay, we have something that links that wheel to other things. Okay? So a pulley is a type of wheel and axle. Now, when we talk about a wheel and axle, the wheel is the big round part. And the axle is always the rod that goes through the center of the wheel. Okay? Just like with levers, wheels and axles also, they fall under some of those characteristics of simple machines. Okay, wheels and axles, or especially pulleys, allow us to transfer a force from one place to another. They allow us to move a load from here to there with less energy in some cases than would otherwise be required. They allow us to change the amount of force or the magnitude of the force required to move a load. Depending on the type of wheel and axle we set up, we might have less effort to put into it. Okay? And they also allow us to increase or decrease the speed of the motion of an object. If we had to push a car down the hill, okay, and it didn't have wheels on it, that car wouldn't get very far. That car weighs over 1,000 pounds. But you put wheels on that car, and pushing that car takes a lot less effort. Or pushing that object on wheels takes a lot less effort.
Unless you put on a neutral or something.
The idea of a wheel and axle does not necessarily have to be an actual wheel. There are objects out there that accomplish a task that involves rotation or circular motion, and they're not actually even wheels. But because of the way we use them, they fall under a wheel and axle label. A screwdriver is a wheel and axle because you have the handle of your screwdriver, and then you've got that metal part that you put into the actual screw. Okay, the screw's here, and it goes in. You put that in, and you turn the handle. The handle is the wider part here. It is the wheel, and the actual rod here is the axle in this system. Okay, so something like a screwdriver is a wheel and axle. A steering wheel in a car. Okay, if you've ever tried driving a golf cart or a go-kart or whatever, okay, because you obviously haven't been driving cars, when you turn that big wheel, that actual cylinder that's in the middle of the car wheel is actually the axle there, and that axle is linked to the tires on the front tires of the car. As you turn to the left, the front wheels turn to the left. As you turn the wheel to the right, the axle turns to the right. It causes the front wheels to turn to the right. Okay? So in the case of any wheel and axle, the wheel will always have a much larger diameter, and the axle will have a much smaller diameter. Be teeny tiny in comparison. Okay? The larger diameter circular motion object is the wheel. The smaller diameter one is the axle. So just like in levers where we've got 3 classes, we do have 3 specific types of pulleys that we're going to look at. And these pulleys accomplish specific tasks. And at the end of the day, you need to remember that a pulley is nothing more than a wheel with a little axle in the middle. And this is either attached to something, okay, and it allows you to actually pass a rope through it, and it allows you to put an effort in order to raise a load. A pulley is a wheel and axle, all right? The larger wheel is the wheel of the pulley itself that a rope or a chain or whatever goes around. Your clothesline is 2 pulleys together that are linked by a rope, by the actual clothesline itself. Okay? Now, just like with levers, we're going to look at 3 types of pulleys. And they all have specific functions. Some of them are going to make your life easier. Some of them aren't going to make it easier, but they're going to allow you to accomplish a task that you otherwise wouldn't be able to accomplish. The first of the 3 types of pulleys that we're going to talk about is something called a single fixed pulley. Single because there's only one wheel. Fixed because it's attached to a ceiling. Okay, it is full on attached. You can't move it this way, you can't move it that way, you can't move it down, and you can't move it up. It's stuck where it is. All right? Now the cool thing about a single fixed pulley is that it doesn't necessarily it has no mechanical advantage. All right, so a single fixed pulley, so we're going to stick with the colors we've been using. There's my load, and here's my effort. So I have to pull this string down, and that is going to cause the load to rise. But there is 0 mechanical advantage to doing this. It's still going to take us the same effort. And I know you're asking yourselves this burning question. Why would I use a machine if it's not going to make my life easier? The reason single fixed pulleys are used is it's often used for a really large and awkwardly shaped box that you can't necessarily pick up. Okay, or it's in a spot that's really hard to get to or whatever. Okay, so it does have its benefits, but it doesn't lower the amount of effort you have to put in. Okay, it is useful though. All right, so this is a single fixed pulley. So the second type of pulley we're going to deal with is something called a single movable pulley. And we're actually going to do a lab on pulleys, just like we're going to do a lab on levers, and we're going to see the difference that these actual pulleys do for effort. Okay, we're going to see the impact that they have on effort force. Now, a single movable pulley is not attached to an actual ceiling or floor. It's free floating, okay? It's got a hook on it, and you attach the mass to the hook. It's the cord that is actually attached to the ceiling. The cord, the chain, the rope, whatever. And that cord passes through the actual pulley. So in this case, the object, okay, this is usually done by machine or people. You will do this in your lab. The effort goes up in this direction, and it causes the load to rise. Now, a single movable pulley cuts your effort by half, because half of the actual effort required, or half of the load's weight, is taken up by this cord here. Okay, so this string in the pulley. So it's got a mechanical advantage. It's got a pretty awesome mechanical advantage because it lowers your effort by 1/2. Okay, so it only takes half of the effort required. Okay, so it's got a very high mechanical advantage because it cuts, your effort by 1/2 because of this cord. All right? That doesn't happen in a single fixed pulley. So just to reiterate, for the single fixed pulley, the purpose of it is to change the direction of a force. Okay, so it's to change the direction of a load. It's to pick up a load and move it. It doesn't lessen the load, though. Okay, it doesn't lessen your effort. When we're talking about a single movable pulley, it decreases the effort force required. That means it lowers your effort force by 1/2. The last of the types of pulleys, or pulley systems, I should say. So we've got our single fixed, our single movable, and here we've got a multiple pulley system. Now, the reason I really like this image, okay, is because it actually shows the progression of what happens when you add more and more and more pulleys. So first off, we see this single fixed pulley. We have our single fixed pulley over here. And we notice that the load force is 100 newtons. The effort force is 100 newtons. It does not lessen the effort. But as soon as we start to add multiple pulleys, that means more than one pulley, okay? We see that our load force stays the same throughout, 100 newtons. But look at what happens with 2 pulleys. Cuts it by half. 3 pulleys, 1/3 of the force required. 4 pulleys, 1/4 of the force. So here's the deal. The more pulleys you have to a certain extent, the less effort you will have to put into it. However, what you also have to take into account is the more pulleys you have, the more friction you have. Because right now, whereas in a lever we had a very small amount of friction, in a pulley system, we have friction everywhere the rope touches the actual pulley, and we also have friction at all of the wheels and axles. So this is a much more, there's much more friction at play in a pulley than there is in a lever. So the question then becomes, how does friction impact the whole system here? And we know that friction is a force that if my forward motion is in this direction, friction is going to be a force that opposes my forward motion, right? And I know that this pulley system, you're like, well, wait a minute, we're talking about wheels and axles here. So at the end of the day, this is looking at the total number of effort force required. It's not taking into account friction. Friction will actually add a little bit more effort so that you'll have to overcome friction in order to get the job done. But it's still not enough, okay? It's still not as much as it would be otherwise, okay? The multiple pulley system is still super beneficial, even though there's a little bit more friction, okay? So we overcome that friction by having to put in a wee bit more effort to overcome it. And the whole point of using a multiple pulley system is just like a movable pulley system, it decreases the number, the amount, the numerical amount of effort force required. Okay? So it does have a high mechanical advantage. And the mechanical advantage increases the more pulleys you have until you reach this. Like, I mean, if you have 1,000 pulleys in a machine, that's useless. Okay, that's overboard. Okay, you're never going to get to zero effort force. And you're going to get to a point where too many pulleys is actually a problem because it will create more friction. But in the case of like 3 or 4 or 2 pulleys, that is more beneficial than just one. Okay?